All right, hi everybody. This is just a notes over the lesson, section 1.7, simplifying expressions. So just remember, yeah, I'm out today, but that doesn't mean you can't go crazy on me. You still have to take notes. You still have to watch this video. I want remember that I'm going to be checking two things tomorrow when I come in. I'm going to be checking the homework from this that was due today. I'm going to be checking these notes. Okay, I'm going to be checking these notes. And that includes all examples and notes, right? So I want all examples that we do written down, and everything that I highlight really should be written down, okay? And then also I'll be checking the homework given today. Okay, that's the worksheet, and I'll tell you about that a little bit later on. So let's get into the notes. So this is section 1.7, simplifying expressions. Now you probably know how to do a lot of these things within this lesson because it's kind of a topic that it's kind of a middle school topic actually. So you probably know how to do some of this stuff. We're just gonna basically review it. So let's go through. First property that we have to talk about is called the commutative property. Whenever you think of commutative, that word commutative, it's got the root word commute. That means to travel around, to move around, right? When you think about people commuting to work, that means they're driving to work, they're changing locations and going to work, right? So order or change of location, right? That basically means that I can take 2 plus 3 plus 4 and change up the order, make it 4 plus 3 plus 2, and it's not going to change the outcome, which is true, right? 2 plus 3 is 5, plus 4 is 9. 4 plus 3 is 7, plus 2 is 9. Either side of the equation is still 9. I can change the order, and it's not going to change the outcome. Heck, I could even change the order again. Let's go 3 plus 4 plus 2. 3 plus 4 is 7, plus 2 is 9. 4 plus 2 plus 3. Oops, plus 2 plus 3. 4 plus 2 is 6, plus 3 is 9. So I can change the order, and it's not going to change the outcome. Same thing with multiplication. 2 times 3 is 6, times 4 is 24. 4 times 3 is 12, times 2 is 24. I can change the order, and it's not going to change the outcome. That is called the commutative property. So I would write down commutative property, changing order, changing location, and then write down this example. Same thing here with the associative property. Please pause whenever you need to, just to make sure you understand, make sure you can write down, have time to write down these things. Associative property, this is what have to do with the grouping symbols. Whenever you see associative property, think of that root word associate, right? The people that you associate with are the friends that you have, right? That's what that means. So, the people that you have that you associate with, or your friends, your friend group, if you will, right? So you grouping symbols. You group 2 and 3 together to make 5, and then add 4, 9. You group 3 and 4 together, 7, and then add 2, 9. Does not change the outcome, does not change the value. So grouping symbols, that's associative property, okay? So just make sure that I'm not changing order. 2, 3, 4, 2, 3, 4. I'm just changing the groupings. Same thing with multiplication. 2 times 3 is 6, then times 4 is 24. 3 times 4 is 12, then times 2, again, 24. So I can change the grouping symbol, and it does not change the answer. Now, taking a look at both of these are both addition and multiplication only. The commutative property and associative property is only about addition or multiplication. I do not include division or subtraction here, okay? So let's keep it going. Now we have the distributive property. The distributive property distributes a term on the outside of a sum. If I'm multiplying, notice how we wouldn't really write it right there, but there's that 2 times the parentheses, right? So what I can do here, let me change my pen up a little bit, is say 2 times x, 2 times, oops, Get that out of there. 2 times 5. Get my pen back. 2 times x, 2 times 5. I'm basically distributing that 2 to both the x and the 5. So 2 times x is 2x. 2 times 5, 10. Okay, so 2 times x, 2 times 5. Let's keep it going. Pause here and try this one with the distributive property, and then play when you think you've got it. So we distribute 3 to the y and 3 to the 7. You've got to think about that as 3y minus 3 times 7, 21. So that using the distributive property, I distribute that 3 to both the y and the 7 to make it 3y minus 21. Keeping it all in letters, you know, this is algebra. We work with letters a lot. A times b is ab plus a times c, ac. There's the distributive property with just letters. Okay. Make sure there's nothing else on that page. Very good. Let's keep it going. Couple slides left. So, try some on your own. Again, pause and then play when you think you've got the right answer. Again, these are the examples that I'm asking you to write down. So make sure you do them as we go along. 5 times x, 5 times 3. 5x plus 5 times 3, 15. 5x plus 15. 9 times a minus 3. Again, pause and play when you think you've got it. 9 times a, 9 times negative 3. Yeah, I notice that I'm calling that a negative 3. It's just really just a minus 3. So we say 9a minus 9 times 3 is 27. 9a minus 27. That's my answer there. Again, pause wherever you need to. Now watch here. Whoa, whoa, whoa. We've got a negative. Look, we're going to do another example of it. So let me show you one and then you do one. Negative 7 times y, negative 7 times 2. So negative 7 times y is just a negative 7y. But negative 7 times a positive 2 is a negative minus 14. You see how that works? Since I've got a negative and a positive in there, it turns into a minus sign because it would be adding a negative, which we know adding a negative is really just a subtraction. Try one on your own to see if you can get it. Now this one's a little tricky anyway. Negative 2 times x, negative 2x. Now watch what we've got here. Negative 2, negative 7. Negative and a negative times positive 14. You could think about it as like a negative 2x, and then we would do minus a negative 14. But we all know by now that just going to become a big plus sign, right? Okay. Let's keep it going. Try that one. Well, I guess you got to know this first. You can think about this one as, since you see the negative outside, you're going to distribute the negative. You know, we can think about it as distributing the negative, but you think about it as distributing a negative 1 and then a c minus 10. Hate my pen. So pause and try that one to see if you can figure it out. So we have a negative 1c or just a negative c, and then negative, negative. Look here, negative times a negative turns into a positive 10. So negative c plus 10 is my correct answer there. Again, all of these examples need to be in your notebooks. Okay, so those are the properties. Properties, distributive property, associative and commutative properties. You got to know what those properties are and be able to identify them. Okay. Now, we're going to need to use those properties in order to combine like terms. We need those properties, you know, as kind of like our building blocks for algebra, for combining like terms. So what are like terms? Well, like terms, this is a definition for you, have the same variable raised to the same power. That needs to be in your notebooks. Like terms have the same variable raised to the same power. Again, pause if you need to write that down, or pause because you should write that down. Notice how 4x and 3x, they have the same variable term, x, raised to the same power. Notice how they're both to the first power. Their power is both 1 because there's not a power written. Same variable, x and x, same power, 1 and 1. These are considered like terms. Any number that you have without a variable is called a constant. Okay? This 4 is called the coefficient. This 3, another coefficient. A coefficient is just a number next to a variable. Right? So let me show that there. The 1 down here is a coefficient. A 3 is coefficient. Make sure you write this definition down. Coefficient is a number multiplied to a variable. Now, these are not like terms. Even though they both have an x, one is a squared and one is a raised to the first power. So you could not combine these together. If I asked you to simplify this expression, well, this is simplified. That is fully simplified. You would just put that on the answer blank. But, I'm just trying to demonstrate what are coefficients. This is a coefficient. This 1 is a coefficient. This 3 is a coefficient. Okay, so let's combine like terms. Simplify and combine like terms. Looks like I need to put that. All right, let's do blue pen. Why not? Skinny line. All right, so think about like terms. Like terms. I like to use the highlighter when I'm talking about like terms. So I'm going to highlight any of the P terms. 16P, 84P, negative P. Now I'm going to add all of those like terms together. Get my blue pen back here. All right, so I've got 16, 84, and a negative 1, because we think about a negative 1 being right there. So 16 plus 84, that's 100. 16 and 84, just adding the coefficients together, adding because this is my operation. 16, a positive 84 make 80, or 100, and now a minus 1p. So 16, 84, negative 1, 99p. Those terms go away, and I like to cancel them out. I like to cross them out to know that I've used them up. And then plus 10 is sitting out there all alone, nothing to combine with. Okay. So there's my answer. Again, you should be writing these down as we go. Take a look here. Ooh, getting fancy. I've got to do something first. I've got to use the distributive property first. Whenever I see parentheses, please excuse my dear Aunt Sally. Please, parentheses. Got to evaluate those parentheses. And when I say evaluate those parentheses, that means use the distributive property. 6x plus 18. That's using the distributive property. Now I'm going to copy down everything else. Oops. Get my pen back. I'm going to copy down everything else that I didn't use. Bring down the minus 3x exactly as it was. Bring down the plus 4 exactly as it was. And I'm not going to change anything that I don't distribute with. Now I can combine like terms. Look, 6x and a negative 3x. Those are like terms. They come together to make 3x. 6 minus 3 is 3x. 18 and 4 are my constants. They come together to make 22. 3x plus 22 is my answer. Try this one on your own. Think about, can I simplify that? The answer, no. I cannot simplify that. I talked about that before. Since they're both m, but one's an m squared and one's an m to the first power, so I can't do anything with it. It's fully simplified. So you could write that answer exactly as it is. Okay, that is the fully simplified version of that expression. Try this one on your own. Look, I've got another distributive property here. 5x minus 40 minus x. Notice that I brought down this minus x, didn't change it at all. I didn't do anything with it, so I'm not changing it. 5x minus 1x. See, remember, always a 1 sitting out there. Minus 1x, 4x minus 40. And that's my answer. Fully simplified down. Pause when you need to, folks. Whoa, that escalated quickly. Holy cow. 2 distributive properties. Womp, 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 I'm going to do both of them at the same time. 5 times a 2a. Now, remember, whenever you got a coefficient out front here, you got to take this 5 times 2a. 10a. 5 times a negative 6, minus 30. 3 times 4a. 12a. 3 times 3 gets us a 9. Now I can combine like terms. 10a, 12a to make a 22a, negative 30, positive 9, minus 21. Negative 30 plus 9. There's my answer. Try this one on your own. Working with some negatives in there. Watch out here. Pause, and then play when you think you got it. I distribute this negative sign, and I get a negative 6y minus 1. Now watch here. I'm going to distribute a negative 3 in here. Watch out for that, folks. That's tricky. You get a negative 3 times a 2 to get a negative 6y. This one should definitely be in your notebooks because this, really tricky. Negative 3, negative 5, positive 15. Whoa, weirdo. Combine like terms now to get a negative 12, a negative 1, and a positive 15 gets us a positive 14. Whoa, that's a weird one. Make sure you write that one down. I'll leave that there for a sec. Okay. I think that's it. Awesome. So again, just as a reminder, what am I going to check tomorrow? I'm going to check the homework that was due today. I'm going to check the notes with those examples. I will not, I'm giving you points for this. I will not accept notes without those examples written. And then the homework that will be given.